We know the event that wiped out the dinosaurs 66 million years ago. A massive asteroid slammed into Earth, right near the present-day Yucatan Peninsula. But before geologists found that crater, they were looking at a very different suspect. Over in India, there is a sprawling igneous rock formation known as the Deccan Traps. For 600,000 years, a supervolcano blanketed a third of the Indian subcontinent in layers of lava, exactly when the dinosaurs died off. The Deccan Traps sit on the exact opposite side of the planet from the asteroid's impact zone, pointing to a terrifying connection. Shockwaves might have rippled entirely through the Earth, converged on the antipode, and fractured the crust to trigger the supervolcano. Earth's geological history is so incredibly volatile that a mass extinction doesn't always wait its turn. You can be hit by a giant rock from space and a continent-sized lake of lava at the exact same moment. If we live in a solar system that acts like a shooting gallery, and on a planet that regularly paves itself over with magma, it raises an obvious question. What is the next major natural disaster that humanity is statistically overdue for right now? To answer that, we can't rely on doomsday prepper paranoia or disaster movies. We have to run the numbers and conduct a strict mathematical audit of the deadliest events in human and geological history. If we look at localized disasters, floods and droughts have been the deadliest forces in our history. Between 1783 and 1792, India suffered the Chalisa and Dojibara famines back-to-back. The resulting crop failures starved an estimated 11 million people. A century later, systemic agricultural failures and harsh droughts scaled those numbers up drastically. Across the 19th and 20th centuries, a series of catastrophic famines in China resulted in death tolls reaching up to 55 million. But famines are limited by geography. If you look at threats capable of sweeping the entire globe, the numbers jump even higher. Biological plagues operate on a terrifying scale. The plague of Justinian in the 6th century and the 1918 Spanish flu pandemic both pushed the upper limits of human mortality, with estimates suggesting each outbreak claimed up to 100 million lives. Yet even those pale in comparison to smallpox. Over a 500-year span, before modern medicine eradicated it, that single virus killed an estimated 500 million human beings. The human species weathered every one of those local and biological horrors. We survived. For a disaster to pose a true existential threat to humanity as a whole, it requires a planetary reset button. Throughout Earth's history, the geologic record shows exactly two mechanisms capable of wiping the slate clean: asteroid impacts and supervolcanoes. About 250 million years ago, a supervolcano event known as the Siberian Traps triggered the Permian-Triassic extinction, often called the Great Dying. The ensuing climate catastrophe extinguished roughly 95% of all species on Earth. To know if we are due for one of these planet killers right now, we have to calculate the statistical intervals of deep time. This timeline visualizes the geological data. Extinction-level impactors, the exact size of the Chicxulub asteroid, strike Earth roughly every 100 million years. The last one hit 66 million years ago. Mathematically speaking, that leaves us with a comfortable buffer of about 30 million years before the cosmos takes another shot at us. What about the crust beneath our feet? The most recent supervolcano eruption on record happened at Taupo in New Zealand. This diagram scales things down to the volcanic threat level. Supervolcanoes tend to erupt every 50,000 to 100,000 years. The Taupo event occurred roughly 26,500 years ago. Even if we calculate using the most aggressive lower bound of that estimate, we are statistically clear for another 26,000 years. From a purely mathematical standpoint, we are entirely safe from both the cosmos and the crust. But statistics can be blind to the present. Right now, global species are dying off at rapidly accelerating rates, leading biologists to argue that the Earth is already in the middle of its sixth mass extinction. It's known as the Anthropocene extinction. It isn't being driven by rocks from space or pools of magma, but by a single species expanding, consuming, and rapidly stripping the planet's resources faster than they can replenish. We don't need to look at the stars or deep underground. The extinction-level disaster humanity is statistically overdue for is ourselves.